Welcome. This is Coach Dorf. We're in section 3.2, and we're looking at a homework example. In this one, we're supposed to differentiate a function that will have to use the quotient rule in order to find the derivative. And we have to use the quotient rule because we have a numerator part and a denominator part. So let's begin. We have f prime of x equals. The quotient rule says that I take the denominator, and I put that in the top, in the numerator, times the derivative of the numerator minus the numerator times the derivative of the denominator, and that's all over the denominator squared. All right, so then we work on this. In the numerator, we have x e to the x in parentheses times. Now we have to take the derivative of the quantity x times e to the x. Here we have to use the product rule because we have x times e to the x and we're taking that derivative. So the product rule says I take the first times the derivative of the second plus the second times the derivative of the first. All right, then we subtract x e to the x times the derivative of the parentheses x plus e to the x. Now that's not a product rule, that's an addition rule. So we take the derivative of each term individually. The derivative of x is 1. The derivative of e to the x is e to the x. Again, that's all over the denominator squared. All right, and so then again on the top we have x e to the x. Now simplifying the next part, we have x times the derivative of e to the x, which is just e to the x, plus e to the x times the derivative of x, which is 1. So 1 times e to the x will just be e to the x, minus x e to the x times 1 plus e to the x divided by the denominator. All right, now we're going to have to multiply these terms together. So let's use some colors here. So I have to go x times e to the x. So that's going to give me an x squared e to the x. Then the next term, I'm going to have x times e to the x. That's going to be x e to the x. Then I'm going to have e to the x times x e to the x. So that's going to give me an x. Now I have 2 e to the x's there, so that's going to be e to the 2x. And for the last one, I have e to the x times e to the x. So e to the x times e to the x, again I have 2 e to the x's, so that will be e to the 2x, because I'm multiplying those 2 e to the x's together. All right, on the other side, we have x e to the x times 1 with a subtraction sign in front of it. So that's going to be x e to the x. And then the last one, remember I still have this negative that gets distributed. This negative still gets distributed, so I have a negative. But now I have x e to the x times e to the x. So that's going to be minus x e to the 2x. All right, and that's all colorfully over the denominator squared, or the denominator, which was the original denominator squared. All right, so let's see. Can we cancel anything out at this time? Yes. So this x 2e to the 2x cancels out with a negative x to the x, and the x e to the x cancels out with a negative x e to the x. So that will give me then an x squared e to the x plus e to the 2x on the top divided by x plus e to the x squared. Now at this point you may think, well, can I do anything more to this? Well, you could factor out an e to the x, and if you did that, you could factor that out on the top, you would have an x squared plus e to the x, and then you'd have the denominator. So which one of these is the correct answer? Which one's better? In this case, it really doesn't matter. I'm fine with just going with the first one we had there and saying that that's my final answer. If, however, on the second one, if I factored it out and I could reduce something on the top with something on the bottom, then it would be better to factor it like we did in this last case here. But here we have an x squared plus e to the x on the top, and in the denominator we have an x plus e to the x in the bottom. So they don't cancel each other out because one has an x squared, one has an x. All right, hope that helps.